Here we've got the graph of y equals x cubed plus 24x plus 3. And what do you notice about the gradient of this graph? Here's the line here. What do you notice about the gradient? What you should notice is that it's always positive. Remember, a positive gradient is in that direction, a negative gradient is in that direction. What we can do is we can use calculus, the differentiation that we've already learned in C1, we can use calculus to prove this. So here's the equation, and let's differentiate. Let's get dy by dx. That's 3x squared plus 24. Now, x is a real number, so that means that x squared will always be positive. If you square any number, the answer is positive, whether it's negative or positive. Minus 2 squared is 4. 2 squared is 4. So x squared is positive. 3x squared is obviously positive. If you add 24 to a positive number, that's always positive. So therefore, dy by dx is positive for all values of x. So in this case, it is an increasing function, because the graph is always increasing. It's an increasing graph or function. Squash that in there. So an increasing graph, dy by dx is always positive. But obviously for a decreasing graph, dy by dx is always negative. Here we've got the graph y equals x cubed plus 3x squared minus 9x. And you can see from here that up to that point there, the graph is increasing. Here the graph is increasing. But here the graph is decreasing. Decreasing means it's got a negative gradient. Increasing means it's got a positive gradient. Let's use algebra to prove this. So we're going to use calculus, obviously, because we're looking at the gradient. Differentiate x cubed is 3x squared. Differentiate 3x squared, that's 6x, and that's then minus 9. 3 is a factor of all of those, so it's x squared plus 2x minus 3, and then that bit factorizes to be x plus 3, x minus 1. Now, if x is bigger than 1, then 3x plus 3, x minus 1 is going to be positive. If x is smaller than minus 3, 3x plus 3, x minus 1 is also going to be positive. That's because if we put a number smaller than minus 3, like minus 4, in there, that's going to be negative, that's going to be negative, two negatives multiplied together to make it positive. But if x is between minus 3 and 1, then one of these is going to be negative and one is going to be positive. So to be more precise about that, we can say that if x is between minus 3 and 1, this term here is going to be positive and this term here is going to be negative. So if we've got two things times together, one positive, one negative, the whole thing is negative. Now all of this is about the gradient. This is all about the gradient. So when x is between minus 3 and 1, the gradient is negative. When x is between minus 3 and 1, it's a decreasing function. But when x is bigger than 1 or smaller than minus 3, the gradient is positive, so therefore it's an increasing function. So here we are, between minus 3 and 1, the gradient is decreasing. It's decreasing, it's going down. But if it's smaller than minus 3, if x is smaller than minus 3, or if x is bigger than 1, the graph is increasing. Notice at this point x equals 1, at this point x equals 3, minus 3. X equals minus 3. Here we've got the graph of y equals x to the power 4 minus 32x. What are the coordinates of that point? It looks like x equals 2. Can we be sure about that? Let's prove this algebraically. The sketch is nice, but let's prove this algebraically. Now the key thing about this is that at this point here, at that point there, the gradient is 0. It's called a turning point. It's a minimum point and it's also a turning point. It's where the graph turns. So coming down here, the gradient is negative. From here, the gradient is positive. The graph is decreasing here, it's increasing there. So at that point where it turns, the gradient is equal to 0. So let's prove this algebraically. The gradient function is dy by dx. This allows us to work out the gradient at any point. At a turning point, what did we say before? Dy by dx equals 0. So therefore 4x cubed minus 32 equals 0, because the gradient is 0 at this point. That means 4x cubed equals 32. Let's divide by 4. X cubed equals 8. And yes, x equals 2. That's how it looked on the graph, but now we've proved this algebraically. When x equals 2, we know that y is 2 to the power 4 minus 32x. 2 to the power 4 is 6. 2 to the power 4 is 16, and then it's 32 times 2. So it's 16 minus 64, so that's minus 48. So the turning point is at 2 minus 48. Let's find the turning points on this graph. So we need to differentiate. 2 3s are 6, that's 6x squared minus 30x plus 24. At a turning point, dy by dx equals 0. So therefore 6x squared minus 30x plus 24 equals 0. 6 is a factor, so it's x squared minus 5x plus 4 equals 0. That factorises. It's going to be x minus 4, x minus 1 equals 0. So we've got three things times together to make 0. 6, x minus 4 and x minus 1. If things times together to make 0, one of them must be 0. Well, 6 isn't 0, but x minus 4 could be 0, and x minus 1 could be 0. So therefore x equals 4 or x equals 1. So there's turning points when x equals 4 and when x equals 1. So what are the coordinates? Well, the coordinates are 4, and then I need to put 4 into this equation. If I put 4 into that equation, it works out to be minus 10. And then I need to put 1 into this equation. If I put 1 into that equation, I get 17. Now, are they minimum points or maximum points? It's not clear, we don't know yet, we haven't sketched the graph. We could sketch the graph, but we can also use calculus to determine whether these points are maximum points or minimum points. Let's consider what a minimum point looks like. Here's a minimum point. The dy by dx is 0 at this point. What's the gradient there? Let's say the gradient there is probably about minus 4. What's the gradient? What's the gradient here? Probably about minus 3. What's the gradient there? Probably about minus 2. And probably about minus 1 there, then 0 there, then 1, then 2, then 3, then 4. As a general rule, you can see that as the x numbers increase, the gradient increases. So the gradient itself is an increasing function. So as we go through here, the gradient is getting bigger and bigger all the time. It's going from minus 4, minus 3 and so on up to 4. So this means that at a minimum point, dy by dx is increasing. So how can we work out whether dy by dx is an increasing or decreasing function? Well, we need to differentiate again, because if this function here is an increasing function, then we can tell that by differentiating again. So I want to see if this is an increasing function. I'm going to differentiate again, and the way to write this is d2y by dx squared. You might think, why don't you just do dy by dx and put a 2 by it, because that looks like the gradient squared, it looks like that. So you don't do that, we write it as d2y by dx squared. Differentiate again, 12x minus 30. So where were our two turning points? Our turning points were when x equals 4 and x equals 1. So when x equals 4, d2y by dx squared is 48 minus 30, which is 18. So that means that dy by dx is an increasing function at that point, because that is positive. So therefore at 4 and what was it, 4 minus 10, the graph is a minimum. Then we need to do the same for x equals 1. So when x equals 1, d2y by dx squared is 12 minus 30, that's minus 18, which is negative. So if the gradient itself is decreasing, for example going from 4, then 3, then 2, then 1, then 0, then minus 1, minus 2, and so on, if the gradient itself is decreasing, these numbers are decreasing, 4, 3, 2, 1, if it's decreasing, then we know that it's a maximum point. So therefore we've got a maximum at 1, what was it, 17. So we know if d2y by dx squared is positive, it's a minimum. If d2y by dx squared is negative, it's a maximum. But what happens if d2y by dx squared equals 0?